Lesson 0.3 has us continuing with solving inequalities. We'll also work a little bit with equations, focusing on absolute value today. The definition for absolute value is the distance away from zero on a number line. The key with absolute value is it's always positive. When you're asked to find the absolute value, you put absolute value bars on the outside of your expression. So if I want to find the absolute value of 5, that simply means how far away is 5 from 0 on the number line, and that just equals 5. Even if your term is negative initially, negative 150, once you put those absolute value bars around it, how far is negative 150 away from 0 on a number line? It's positive 150. Distance isn't measured in a negative value. Positive 3 and negative 3 both have the same absolute value. They're both 3 units away from 0 on a number line. When given an equation that contains an absolute value, follow these 3 simple steps. The first step in solving would be to isolate the absolute value term. Again, thinking about getting a variable by itself, you're going to use those rules for PEMDAS but backwards. Get rid of anything that's being added or subtracted on the outside of the absolute value, and then anything that's being multiplied or divided. From there, what you'll do is you'll split the equation into 2 parts, going both distances away from 0 to the right and left on a number line. Last but not least, once you've eliminated the absolute value portion of your equation, solve each remaining set of equations. Here's our first example. The absolute value of x plus 6 is equal to 10. Our first step is to isolate the absolute value term. Notice there's nothing on the outside of that, so step 1 is done, it's isolated. Step 2, to split it. When you split an absolute value equation and you want it to equal 10, that means you could go 10 to the right or 10 to the left on a number line. What you can then do is say that x plus 6 could equal positive 10 to the right, or x plus 6 will equal negative 10. From there we solve. If we subtract 6 from each side, we would get a possible x value of 4. Or the other option, if we go the other direction and subtract 6, x could equal negative 16. If we plug either of those values into the equation and then take the absolute value of that result, our answer would be 10. The next example is a little bit more complex than that. There's a lot of things happening on the left side of that equation. Notice step 1 for isolating the absolute value, we want to get this inside part all by itself. So we need to get rid of the 5 and the 10. Thinking of PEMDAS but backwards, let's get rid of the minus 10 by adding it to the other side. We still have 5 on the outside times the absolute value of 8x minus 9 on the inside is equal to 35. Next, to isolate the absolute value, we'll eliminate that 5 on the outside using division. That gives us the absolute value of negative 8x minus 9. On the right-hand side, that will equal 7. So here's where we have to be careful. When we split this for step 2, we're not going to change anything on the inside. We're going to say that negative 8x minus 9 could equal 7, or, and I'm going to pause this for a second. There we go. I quickly ran out of room on that one. All right, back to the equation. Negative x minus 9 equals 7, or negative x minus 9 is equal to negative 7. And we would solve both of these. This will be good practice for you. Pause the video and solve each of them. Once you have your 2 values for x, press play and we'll see if we get a matching set of answers. Looks like I really ran out of space. I had to go off the page. Sorry about that. Hopefully you got that work to fit. We get 2 solutions for x that would make that absolute value a valid equation. When x is equal to negative 2 and when x is equal to negative 1/4. So here's the key with these equations. Your x value can be negative, but absolute value itself can't be negative. So that's kind of why I knew I could go over into that last example. Take a look at what it wants us to find. What values have an absolute value equal to negative 20? Well, if absolute value is the distance away from 0 on a number line, distance isn't measured in negative amounts. Therefore, because of that negative, this whole entire equation is not possible. You can't find a value for x and take its absolute value and have it equal negative 20. When solving inequalities, we'll use the same steps as solving equations. The type of inequality that we start with will predict the type of answer we end up with. If you have a less than or equal to inequality, that means you have an AND system where you put your absolute value in the middle. If you have greater than or equal, you have an OR system, and you'll split it in two parts, kind of like the equations up above. Let's see what I mean by an example. In our first example, for example 3, absolute value of x plus 8 is greater than 9. So the first thing we want to do is isolate our absolute value. We're going to get that absolute value of x by itself, and I'll subtract both sides by 8. We still have the absolute value symbol on the left. Greater than 9 minus 8 is 1. Notice this matches with the OR definition. Because of that, when we split this, we're going to split it by separating it with the word OR. We'll say x is greater than 1, so we don't do anything different. But once we write the word OR, we do a switch it, change it. We keep x the same, we switch the inequality, and we change the sign. So it's a switch it, change it. X can be greater than positive 1 or less than negative 1. No matter what values you plug into your inequality, as long as those restrictions are true, the absolute value of x plus 8 would be greater than 9. On your number line, we'll take a look at what this solution set would look like. Key with your variables, if the variable's on the left, the arrow that's associated with it will go in the same direction on your number line. If x is greater than positive 1, I would put an open circle at positive 1, and my arrow for all the solutions would also go to the right. Or x is less than negative 1, so I'm going to put another open circle at negative 1. Notice the direction of the arrow goes to the left, so my arrow will go to the left on the number line. All right, on the next example, what I'd like you to do is simply isolate the absolute value. Can you get absolute value of x plus 4 by itself? Just get to that point and then we'll move on together. So pause the video, get x plus 4 by itself, and then we'll continue on. How did you do? Did you get the absolute value of x plus 4 is less than or equal to 5? I sure hope so. That would be the correct spot for step 1, isolating that absolute value. Based on the inequality, this is an AND inequality. Anytime you have that sort of inequality, what you'll do is you'll keep the x plus 4 in the middle. You'll keep the less than or equal to 5 on the right because 5 is positive. On the left, you're going to run the same kind of direction for the arrow, but you're going to make your 5 negative and keep the arrow in the same direction. What this means is x plus 4 is technically greater than or equal to negative 5 and less than or equal to positive 5. And now we want to get x by itself. Whatever you do to x and that inside, you're going to put on the left and on the right. To get x by itself, we're simply going to subtract 4. But if we do that in the middle, go ahead and subtract 4 on the left and 4 on the right. Simplifying all 3 sections for this compound inequality is going to require us to have a little bit more space over here. We're good to go now. Negative 5 minus 4 on the left-hand boundary is negative 9. Now x is in the middle by itself. And then on the right, 5 minus 4 is 1. Since x is in the middle, we're actually not going to have arrows in our answer. The segments will actually connect. So let's go ahead and draw that number line. I had to make my number line pretty small to get the numbers to fit to show that spatial representation for our answer. -9 is our boundary on the left, and x can be greater than or equal to it. That means we'll use a closed circle for our solution. The boundary on the right is +1, and x can be less than or equal to that. We'll use another closed circle. Since x is anywhere in between, instead of drawing arrows, we're just going to connect up and over. As long as x is somewhere in between those values, our original inequality will be a true statement. And that's it for today, you guys. This is as far as we'll go for our notes today. Next week, we'll finish up kind of what that interval and set notation solutions look like at the bottom.